Here we're looking at linear functions, and remember, linear functions are just functions that when graphed give us lines. And a line is just kind of a string of points that shoots off in a straight direction here and continues forever in each direction. And the first thing we're going to look at with linear functions is slope. Remember, there's three ways to look at slope. We've got our typical slope formula that we tend to use, and this one we kind of use when we have 3 points that are or 2 points that are given. If we have 2 points that are given, we plug them into the slope formula, and basically we do the subtract the y values and then subtract the x values and then divide them. And when we do that, we just have to make sure that we keep everything in the proper order. So if I have 2 points and I use the first point as my y sub 2, I have to use the x value from that point as my x sub 2. So the order in that is very important. The next one here, this is really the same thing as the first one, but it's a little bit simpler way of looking at it. It requires a little bit more thought, but a little less work when it's all said and done. And this is the symbol delta that we have here. Delta means change, okay? So we're talking about change in y over change in x, all right? So basically I look at the y values and compare them and ask myself, how did y change? And I write that number down, and then I ask myself, how did x change? I write that number down, and then we divide. And then this last one, the last one we have here, this is typically used when we're looking at a graph, okay? So I choose 2 points that are actually on the graph, and I do rise over run. I basically count up, straight up and straight over from one point to the next and say, okay, how far up did I have to go? How far over did I have to go? All right, for example, I've got 2 examples here, and yes, these are 2 separate examples. One where I have 2 points, and one where I have a line graphed. And so this first one, there's 2 good options for doing this one. I can either use my formula, I'll do my formula first, and then I'll show you the change in y over change in x. So if I'm doing the formula here, the first thing I want to do is identify which of these values are going to be x sub 1 and which one's going to be x sub 2 and which one's y sub 1 and y sub 2. So for me, I'm just going to make this first one x sub 1 and y sub 1, and this would be x sub 2 and y sub 2. And again, it's important to label those because the order matters here when you're going through that. So now my slope equals, I'm going to do y sub 2, which is the 4, minus y sub 1, which is the negative 5, over x sub 2, which is the negative 2, minus x sub 1, comma there instead, let's try again, minus x sub 1, which is the 4. And now I just want to go ahead and simplify this. This is like adding the opposite, so that's going to give me a 9. Underneath here, when I subtract those, that gives me a negative 6. Again, we could change that to adding the opposite if that makes a little bit more sense to us. That gives me a negative 6. And then when I simplify this, it's going to simplify to a negative 3 halves. Okay? So that's my slope, is a negative 3 halves. I can do the same thing in terms of change in y over change in x. And when I do that, I essentially just look at from one point to the next. So in this particular example, I might look at this this negative 5, and then I look at the next y value, which is the 4, and I ask myself, how did y change? Well, it went from negative 5 to positive 4. It went up 9, so I write down a positive 9 for my change in y. Okay? And then I do the same thing with the x. If I look at these x values, it was a 4, now it's a negative 2. My x value has decreased, and it's decreased by 6, so I put down a negative 6 in terms of how it's changed in terms of the x. And now once again I simplify, so I find out that my slope is still a negative 3 halves. So those are the 2 ways to really look at this example. Again, I prefer just doing change in y over change in x. It's really the same process, and really you're even still subtracting, but it's just a nicer way to think about it, and it's a little bit quicker. Okay? With the next one, I just need to find 2 points that this thing absolutely definitely goes through. It looks like it goes through this point, and it goes through this point for sure. And so now I just count from one to the other. So I count up, and then I count over. I'm just going to do rise over run. So when I count up, it looks like to get from one point to the next, I have to go up 3 units. And then I count over, and to get from one point to the next, it looks like I have to go over 2 units. So my slope is 3 over 2. Okay? That's rise over run. When we talk about the intercepts of a linear equation or a linear function, the x-intercepts are where it crosses the x-axis, and they exist when y equals 0. That's kind of the algebraic scenario. So graphically, it's where it crosses the x-axis. Algebraically, it's where y equals 0. The y-intercept, again, graphically, it's where it crosses the y-axis. Algebraically is where x equals 0. And so when we look at something like this, here's the graph of this thing, and I want to look at the x and y intercept, and just remember that the y-axis is the vertical axis and the x-axis is the horizontal axis. So now when I'm identifying these points, the y-intercept is right here. It's where it crosses the y-axis, and it looks like a positive 4. And I'm just going to write that down as an ordered pair. So the y value is positive 4. As an ordered pair, that's 0, 4. And now we can see it in terms of the algebraic aspect of this. It's where x equals 0. And then when I look at the x-intercept is right here at 2. And again, that's the ordered pair 2, 0. And so now we can see algebraically the y value is 0 when we do that. So keeping them as ordered pair helps us to remember that fact. When we look at something like this guy, if I want the x and the y-intercept, again, we're just going to do it algebraically this time. So the x-intercept is when y equals 0. So here's what I'm going to do. I'm just going to plug a 0 in for y. And now I'm just going to simplify this for x. So right here I've got 3. Well, that's minus 0, so I just left with 3x equals 12. And now I'm going to divide each side by 3. Find out that x equals 4. Okay, so my x-intercept is 4, but more specifically it's the ordered pair 4, 0. Because remember, it's when y equals 0. And I even plugged the 0 in for y, so essentially I'm identifying an ordered pair. I do the same thing for the y-intercept, except this time I plug a 0 in for x. So I plug a 0 in for x. And when I do that, of course, that first piece is gone, so I just have a negative 4y equals 12, and I divide each side by a negative 4. And I find out that y equals a negative 3. And again, I write that as an ordered pair. That's the y value is negative 3. That's when the x value is 0. So it's the ordered pair 0, negative 3. And really what that's really excellent for is for graphing this thing, especially when I have something that's written in my standard form. And so I find these two intercepts. Well, now I've got 4, 0, which is right here. I've got 0, negative 3, which is down here. And so now I can easily draw a sketch of this line with just those 2 points, and that's the easiest way to graph this particular example. Okay? The next thing we're going to look at is slope-intercept form, and this is one of those things that most of us are probably very familiar with, y equals mx plus b. Remember, m is the slope, so this guy right here is the slope, and then this guy right here is the y-intercept. Okay, so basically the y-intercept right here gives us a starting point, and then the slope tells us how far up and over to go using rise over run in order to graph our line. Okay? So if we look at an example here, right here in this particular example, I can see the y-intercept. The y-intercept is right here. Okay, it's the negative 1. And again, if I want to think of that in terms of an ordered pair, the y-intercept, the y value is negative 1, the x value is 0. So it's 0, negative 1. Again, that gives me a starting point, so I'm going to start at 0, negative 1, which is right here. And then the slope is right here in front of the x. That's a 2. And really that's like, if I think of it this way, that's like 2 over 1. That's giving me rise over run. In other words, it's telling me to go up 2, so I count up 2 and then over 1. And I put a point on this thing, and I didn't do a very good job. Let me try again. So that puts me right here. And I can keep doing that, up 2 over 1, up 2 over 1. And it allows me to graph this line pretty easily. Okay? And the next one, again, I have these two values. I've got the y-intercept at 7, which means the ordered pair is 0, 7. So I'm going to start at that point. So that's my starting point. It's way up here. And then I've got a slope of negative 3. Again, I can think of that as negative 3 over 1. It's rise over run. And if the rise is negative, it means instead of going up, I go down. So I go down 3 and then over 1. Down 3 over 1, down 3 over 1. And I can do that as many times as needed to give me a nice accurate graph. Okay. And the next one, again, the y-intercept right here is the negative 3. So that's my y value. The x value is always 0 for my y-intercept. So it's the ordered pair 0, negative 3. So I'm going to start there. That's my starting point. and then it's got a slope right here of 3/4, and that's already written as a fraction in terms of rise over run. So that means I go up 3/1. So I'm going to go up 3/1, or sorry, up 3/4. What am I saying? Up 3/4, and then I can graph that line. Okay? So again, when it's not written as a fraction, you put it over 1, and then you can see your rise over run pretty easily. When I look at something like this, this is the example we did on the previous page using the x and the y intercepts. This time we'll do it in terms of slope-intercept form. If I wanted to use slope-intercept form for this one, what I have to do is I have to solve this equation. I have to rewrite it in terms of y. So I have to subtract the 3x from each side. So I end up with a negative 4y equals a negative 3x plus 12. And now from here I've got to divide by that negative 4. So when I do that, I end up with y equals, this is my distributive property right here. I'm going to divide each piece. So when I do the negative 3 divided by negative 4, it gives me a positive 3/4. And when I do the 12 divided by the negative 4, it gives me a negative 3. And so now I can see this thing in terms of slope-intercept form. I've got my y-intercept at negative 3, and I've got a slope of 3/4, so I go up 3/4. And this is actually the third time I've graphed this one, because if you look at the example right above it, that's the line we just graphed. So multiple ways to graph the same thing. Some of the special cases that we run into with slope-intercept and graphing lines is vertical and horizontal lines. Vertical lines have a slope that's undefined because slope is really how steep something is. That's what it's really measuring here. It's rate of change, it's how steep something is, it's how much it's increasing each time we move over a unit. And a vertical line is so steep that we essentially can't measure it anymore, so the slope is undefined. And when that happens, we kind of break away from our typical y equals mx plus b because we can't really define it that way anymore. So we end up with x equals c. In other words, x equals a constant term. All right, that's our equation for a vertical line. And then a horizontal line is where the slope equals 0. And if you think about it this way, if you have y equals mx plus b, well, if the slope is 0, essentially this piece gets crossed out, so we end up with y equals a value. Y equals the y-intercept. And that's why for horizontal line we get y equals c, y equals some constant value for the equation of our line. Okay? Yeah, if we look at a couple examples, just identifying the slope and trying to decide if this thing is a vertical or horizontal line. I'm going to do this in terms of change in y over change in x because I think it's a little bit easier. So right here I'm going to do the slope. Right here the y value was a negative 5, now it's a positive 7. So my y value has gone up 12 units, so I put a 12 up top. My x value was a 4. It's still a 4, it hasn't changed, so the amount of change here is 0 for my x values. And if I do 12 divided by 0, that's undefined. I can't do that. Okay, so the slope here is undefined, which means I'm dealing with a vertical line. Okay. If I look at the next one, I can do the same thing. I look at these y values. The y was a 3, now it's a 3. The y value hasn't changed, so my change in y is 0, which represents no change at all. And then my change in x, it was a 2, now it's a 6. So my x value has gone up 4. So now I have 0 over 4, which is just 0, which means I'm dealing with a horizontal line. Okay? If I look at the next one, again, the change in y was a negative 1, now it's still a negative 1, so the y value hasn't really changed, which means my change in y is 0. My x value was a 1, now it's a negative 1. It's gone down 2 units to get from 1 to negative 1, so that's a negative 2. When I divide that, that gives me a 0, which means, once again, this is a horizontal line. In the next one, we're going to do the same thing, change in y over change in x. So look at the y values, and right here, the y value was a 3, now it's a negative 3, so it's gone down 6. So my slope is going to have a negative 6 over The x values here didn't change. It was a 2. Now it's still a 2. So the change in x is 0. It's nothing. And now when I have something divided by 0, that's undefined. So the slope on this one is undefined, which means I'm dealing with a vertical line for this one. Okay, but those are the situations we run into. And now, furthermore, if I wanted to look back at these based on the fact that I know whether they're vertical or horizontal, and I know that the form of a vertical line has to be x equals a constant term, and the equation of a horizontal line has to be y equals a constant term, I could actually write the equation of each of these. Here's a vertical line. The equation would have to be x equals, well, the constant x value that this is going to have to be a 4, because look at the x values in the problem. They're all going to be 4s. Okay? The next one is horizontal, so it's going to be y equals, and that y value is going to be a 3, because that's what all the ordered pairs are going to have as their y value. The next one is another horizontal. It's y equals, well, the y value that all of these are going to have is the -1. That y value is not going to change. And then the last one here, it's going to be x equals, and the x value is a 2. Okay, so when it says that there's a constant value there, it really is constant for all of the x's or all the y's, depending on whether it's vertical or horizontal. Okay. When I take a look at this next one, when I look at something like this, y equals 2, right away, because it's y equals, I know that this thing is going to be a horizontal line. And now, basically, to graph this thing, I know the y-intercept. I know that all the y values really are going to be 2. So I start here at 2 for that y value, and all of them are going to be 2. So it's just a horizontal line that stays at a height of 2 the entire time. And that's what this thing is really saying. Sorry, this line is no good. Let me try that again. But that's what this thing is saying. It's saying that basically we go to a value of 2 and we stay there. All right. The next one, because it's x equals, I know that this is a vertical line. And again, I go to an x value of -4, and I stay there. Whether I go up or down, I stay at an x value of 4. And when we look at all the ordered pairs along these lines, when I look at all the ordered pairs along this line, the x value is always -4. When I look at all the ordered pairs back at the previous line, all the y values are 2. Okay, and that's really what that constant term means. It means those x values and those y values are going to stay constant the whole time. All right. The last thing we're going to look at is parallel and perpendicular lines, just because this deals a lot with slope. Parallel lines are coplanar lines that never intersect. Parallel lines always have the same slope. Okay, and so two lines that never intersect. And if they never intersect, that means they have to be going off at the same angle. They have to have the same slope. All right. Perpendicular lines are lines that intersect at a 90-degree angle. Okay, or right angles. It's like the perfect intersection because when they intersect, essentially you get 4 90-degree angles. All right. And the thing about the slopes of perpendicular lines is that their slopes are opposite reciprocals. Okay. And notice that's two things. It's opposite and reciprocal. So we're going to change the sign and we're going to flip it. All right. So parallel lines have the same slope. Perpendicular lines, the slopes are opposite reciprocals. So if we look at an example here, we just want to find the slope of the line and then state the slope of the line that's parallel to that and the slope of the line that's perpendicular to that. And when we abbreviate these, I'm going to abbreviate parallel lines really with just a little set of parallel lines, perpendicular lines with a little set of perpendicular lines. Okay? So when we look at this first one, let's find the slope. Again, I'm going to do change in y over change in x. So the slope here, the y values right here were a -3. Now it's a +7. So it's gone up 10 units. So I'm going to put a 10 here for my change in y. The x values, we had a 2. Now we have a -4. So it's gone down 6 units. So I'm going to put a -6. And now I just need to simplify that a little bit. Looks like that's going to simplify to a -5/3. All right. So I've got a slope of -5/3. So now the parallel line, let's talk about the line that's parallel to that. So the slope of the parallel lines have the same slope, so that's also going to be a -5/3. And now I need to do the slope of the perpendicular line, which is the opposite reciprocal. So instead of positive, I'm going to make it negative. That's the opposite. And then reciprocal means I flip the fraction. So instead of a -5/3, it's going to be a +3/5. Okay, so I change the sign and flip it, and now I've got the slope of the parallel line and the slope of the perpendicular line. All right. If I look at the next one, again, I'm just going to do the change in y over change in x. So once again, my y value here was a 1, now it's a 4, it's gone up 3. My x value was a 0, now it's a negative 2, it's gone down 2. So that's a negative 3/2 for my slope. So now I just need to identify the slope of the line that's parallel. And parallel lines have the same slope, so that's also going to be a negative 3/2. And then the slope of the line that's perpendicular. And again, that's the opposite reciprocal, so I change the sign, so I make a positive, and I flip it. So that's a positive 2/3. And then the last one here, again, I'm going to do change in y over change in x. The first y value was a 2, now it's a negative 8, so it's gone down 10 units. The next one, the change in x, it was a 5, now it's still a 5, so it hasn't changed, so the change here is 0. And if I have 10 divided by 0, well, that means that my slope here is actually undefined. So if my slope is undefined, well, let's talk about the slope of the line that's parallel to that. Well, the parallel line is going to have the same slope, so that's also got to be undefined. But now let's talk about the slope of the line that's perpendicular to that. This is where it gets a little bit tricky. Let's think about what it means to have a slope of undefined. If my slope is undefined, it means that I'm dealing with a vertical line. All right? So if I want the perpendicular line to a vertical line has to be a horizontal line, and every horizontal line has a slope of 0. Okay? And really, you could think of it back here, if I were taking the opposite reciprocal of this guy and flipping it, this would give me a 0 instead. All right? So a couple ways to think about that. If you just realize that we're talking about a vertical line, we know that the slope of the perpendicular line is horizontal. And that's it.